A machine vise has a single start, square threads of 22 mm nominal diameter and 5 mm pitch. The outer and the inner diameter of the friction collar are 55 mm and 45 mm respectively. The coefficient of friction for the thread and the collar are 0.15 and 0.17 respectively. Machinists can comfortably exert a force of 125 Newton on the handle of the mean radius of 150 mm. Assuming uniform wear for the collar, that is, you have to take the value of mean radius of collar as R1 plus R2 divided by 2. This figure represents here the machinist vise. Here we have a movable jaw. T is rigidly attached to the tongue. A and B is called as tongue. And this tongue is loosely fitted into the fixed body. Here the collar is not shown, but this one is the same as our machine vise, which one is a single start. So whenever we are given the single start, then we have lead is same as equal to pitch is equal to 5 mm. And we are given here nominal diameter. Nominal diameter is same as equal to DO of 22 mm. In addition to this, the coefficient of friction for thread is 0.15. So we have value of mu is equal to 0.15. We also given the collar dimension, that is the outer value is 55 and inner value is 45. So we have D1 is equal to 45 mm and D2 is equal to 55 mm. And we have to apply here the uniform wear theory. According to the uniform wear theory, the mean diameter of collar is D1 plus D2 divided by 2. So we have 45 plus 55 divided by 2. So we have 100 by 2 is equal to 50 mm. Therefore, we have the mean radius of collar will be diameter of collar divided by 2, which is equal to 25 mm. And we have to take the friction coefficient for collar as 0.17. That is the value of mu c. You have to take as 0.17. Clamping you can do by rotating the handle. So this time, if this knob will come to this position, the maximum length of handle is known, that is equal to 150. So we'll label this one as a length of handle is equal to lowercase l. Uppercase L we'll use for. So this value of L is same as equal to 150 mm. And perpendicular to the plane of figure, we are applying a force here is equal to 125 Newton. So we are applying here a force P, and this force P is same as equal to 125 Newton. How much clamping force developed between the jaw you have to calculate. That is the value of W we have to calculate. We know that the torque required for clamping will be equal to W into dm by 2 into tan of phi plus lambda plus we have mu c into rc into W. This torque we can generate by rotating the handle by applying the force equal to P. So the torque will be same as equal to P multiplied by LH. So we'll equate on the right hand side as a force P, which is applied to the handle, multiplied by the length of handle LH. On the left hand side, first we require dm, then we require the value of phi, value of lambda. Rest value are known to us. RC already known to us. Since we know the value of DO and we know the value of pitch, so we have dm, that is the mean diameter of the screw, will be DO minus pitch divided by 2. In this case, we have DO is equal to 22 and we have pitch is equal to 5 divided by 2. So we have 22 minus 2.5, that will be equal to 19.5 mm. So dm is known. Next value is for phi. We know that the value of tan phi is same as equal to mu, which is equal to 0.15. So from this we'll get the value of phi, that is the angle of friction. This value of phi is tan inverse of 0.15, 8.531. And lambda you can calculate as tan of lambda equal to lead divided by pi multiplied by dm. Lead we have to take as 5 divided by pi, and the mean diameter you have to take as 19.5. In this case, the lead angle lambda is close to 4.66. W here stands for clamping force. Mean diameter is known, phi is known, lambda is known, mu c is known, rc is known. From these two terms, W can be taken common. So we have W into dm by 2. We have dm is 19.5. So we have 19.5 divided by 2 into tan of phi. We have phi is equal to 8.531. 8.531 plus we have lambda is 4.66 plus we have mu c, that is the coefficient of friction for collar, is 0.17. RC already known to us is equal to 25. On the right hand side we are applying a force P is equal to 125. Length of handle you have to take as mm is equal to 150. Solve this, you will get the value of W. So we get a clamping force equal to W is close to 2868.7. This answer will be in Newton. A screw clamp used on the shop floor is as shown in figure. The screw has a single start square thread of 22 mm nominal diameter. That is the value of DO is given and the pitch is given. This time we have single start, so lead will be same as equal to pitch equal to 5 mm. Coefficient of friction at the thread and collar both are equal to 0.15. The mean radius of the friction collar, that is this collar, as a mean radius is equal to 15 mm. Capacity of the clamp is 750 Newton. That is the maximum force we can exert due to clamping is 750 Newton. So that value you have to treat as W value for us. It can be assumed that the operator exerts a force of 20 Newton on the handle. So on this handle the operator can exert a force of 20 Newton. What torque is required to tighten the clamp to full capacity, that is W equal to 750, and the length of handle we have to find out. Torque we have to find out and the length of handle we have to find out. Since here we have single start thread, therefore we have L is equal to pitch and we have given the pitch is equal to 5 mm. The nominal diameter is given as 22 is D0 value, that equal to 22 mm. So we can calculate here the mean diameter dm, that equal to DO minus pitch divided by 2. DO value is 22 and we have pitch is equal to 5 divided by 2. We have 22 minus 2.5 is same as equal to 19.5 mm. The coefficient of friction for screw as well as for collar is given as 0.15 and we have given the mean radius of collar, that equal to 15 mm. The maximum force that we can apply is equal to P. The operator here exert a force of P. That value of force he can exert equal to 20 Newton. Length of handle you have to find out and the torque is you have to find out. In addition to this, he has given the maximum value of the clamping force that we'll treat as W is equal to 750 Newton. In the previous problem, we have done the calculation for the torque required for clamping, which is given as W into dm by 2 into tan of phi plus lambda plus we have mu c into rc into W is same as equal to the external force P multiplied by the length of handle LH. So this value we have to interested is TR and we'll equate the value of TR with P into LH, then we can find out the value of LH. But for this one, first of all we have to find out what is the value of phi. So we know that tan phi is same as equal to mu and we have value of mu equal to 0.15. Solve this, you will get the value of phi close to 8.53. Then we require the value of lambda, that can be obtained as tan of lambda is equal to lead divided by pi multiplied by dm. Because of single start, we have lead is same as equal to p, which is equal to 5 divided by pi divided by dm, and we have dm equal to 19.5. Take tan inverse and find out the value of lambda is 4.66. So we know the value of w, that equal to 750, dm is known, and phi and lambda is also known. Mu c and mu are same value. Rc is also known to us. So we can first find out here tr. So we have tr, that is the torque required, is equal to w is taken common, and we have value of w is equal to 750 into dm by 2. We have dm is 19.5 divided by 2 into tan of value of phi is 8.53 plus we have lambda is 4.66 plus we have mu c is same as equal to 0.15. RC is equal to 15 mm. Using this we can calculate the required torque TR. So we get the torque TR is close to 3402.3 Newton mm. To find out the length of handle, we'll equate TR with the force applied on the handle P multiplied by length of handle. If you take the TR in Newton mm, handle length will come in mm. So we have 3402.3 is equal to 20 multiplied by length of handle. So we will get a length of handle is approximately equal to 170.1 mm. The construction of a shaft straightener used on the shop floor is shown in figure. This figure represents the shaft straightener. Here we have a shaft, and to straight the shaft we are applying the force in a vertically downward direction. That force can be transmitted with the help of power screw. So we have a collar and we have a screw. Screw is fit in a nut, and nut is a stationary due to frame. To rotate the screw we are using here the hand wheel. The screw has a single start square thread of 80 mm nominal diameter, D0 is known, and the 10 mm pitch, that is lead is same as equal to 10 mm. The screw is required to exert a maximum axial force of 10 kN. So maximum force here we can apply is same as equal to W, and that value of W is given as 10 kN. The mean radius of the friction collar is 30 mm. So this collar here has a 30 mm mean radius, and the axial length of the nut is equal to 40. So that data is useless for us. The coefficient of friction at the thread and the collar is 0.12. So coefficient of friction at the thread, that is screw, is given as 0.12, as well as for collar is also equal to 0.12. So we have to calculate here the torque required to overcome the friction in the collar and the screw. The mean diameter of the rim, so this one is the hand wheel, and which is we are calling as a rim because it's a very thin section, is 500 mm. So diameter is given as 500. So we know the radius of the hand wheel, that equal to 250 mm. Calculate the force exerted at the rim to drive the screw. So we require here the torque that will overcome the friction between the collar, screw, and develop a force equal to W, 10 kN. For that one we require a torque, and that torque is developed by applying a force on the hand wheel. So this force P we have to find out, and this force P will act at a distance equal to mean radius. So we'll call this one as the radius, simply R, which is equal to 500 divided by 2 is equal to 250 mm. The total torque required is given as W into the mean diameter of a screw multiplied by tan of phi, friction angle, lead angle. Mu c is the coefficient of friction for collar, Rc is the mean radius of collar, W is again the maximum force that can be applied on the shaft. This total torque is also equal to P multiplied by R, and we want to find out here the value of P. So one by one value will collect here, and then we'll find out the value of P. In case of single start, our lead is same as equal to pitch is equal to 10 mm. And our nominal diameter is given as 80. So our D0 is equal to 80 mm. Therefore, our mean diameter dm is same as equal to do minus pitch divided by 2. Our do is equal to 80 and pitch is equal to 10 divided by 2. That is equal to 75 mm. The coefficient of friction mu as well as coefficient of friction for collar. The coefficient of friction at the thread and collar is 0.12. So this value is given as 0.12. The maximum force that we want to apply is W is equal to 10 kN. Now two values required, one is phi and one is lambda. So we have tan of phi is same as equal to mu is equal to 0.12. So if we take a tan inverse, we can calculate the friction angle phi, which is equal to 6.843. Then we require the value of lambda, that is the lead angle. So we have tan of lambda is same as equal to lead divided by circumference, which is pi multiplied by dm. Lead is equal to 10 divided by pi, and we have mean diameter is equal to 75. Solve this, take inverse, then we'll get the value of lambda. We get the value of lambda equal to 2.43. And the radius of the hand wheel is already known to us is 250. So we know the value of W, we know dm, we know phi, lambda, mu c is also known. RC value is given to us. The mean radius of friction collar is 30 mm. So we have RC is same as equal to 30 mm. So this equation is sufficient to find out here how much force we should exert at the rib tip to drive the screw. So W here can be taken common, and we have W is equal to 10 kilonewton is 10,000. dm by 2, we have dm is 75 divided by 2 into tan of the friction angle phi is equal to 6.843 plus we have lead angle equal to lambda is 2.43 plus we have mu c, that is 0.12. Radius of collar is equal to 30. So left hand side is complete. P we have to find out. The radius of the rim, that is the mean radius of the rim, is equal to 250. Solve this, you can find out here how much force to be exerted at the rim to drive the screw. So approximately we require the force is equal to 389 Newton. The video you are watching is from the app, which is the Mohod class app available on Google Store. And in this app, we'll cover all subjects involved in mechanical engineering for GATE. Join the course directly from your mobile. The link is given here.